All right, so this is an honors only podcast. If you're in standard class, you can watch it if you want. You don't have to, though. So we are going to use stoichiometry to help us calculate a molar mass. Now, you might think, well, we already know how to do that. That's the easiest thing we've done, where you just add up all the masses. However, what if you do not know what the substance is? So I'm going to give you an example. We have 2.23 grams of lead 2 chloride, and that's formed when 0.944 grams of a metal chloride with a charge of +3 reacts with excess of lead 2 nitrate. What is the identity of the metal? So you're trying to figure out the identity of this metal and the chloride. You don't have the molar mass, but molar mass is a good way to help us figure out what that substance is. So molar mass is equal to the grams divided by moles. So if you know the grams and you know the moles, then you can figure out the molar mass. And the molar mass can help us identify a substance. So the first thing we're going to do here is look at the problem to see what information we were given. So we know that 2.23 grams of lead 2 chloride is formed, so that's a product, when 0.944 grams of metal chloride reacts with excess lead 2 nitrate. So we know that this is the limiting reactant, so that is what determines this amount right here. The first thing we need to have a chemical equation here. So let's go ahead and start writing that out. So it says that a metal chloride with a charge of +3 reacts with an excess lead 2 nitrate. So we know that lead 2 nitrate is going to react with some metal chloride. So let's go ahead and write out the lead nitrate. We know our two reactants. So lead has a +2 charge here, and nitrate is NO3 with -1. So lead 2 nitrate is just PbNO3 2. All right, and that's going to react with some metal chloride. So the metal, we don't know what that is, so we're just going to use M. We know it has a charge of +3, it's stated right there. Chlorine has a charge of -1. So the formula should be MCl3. Okay, and that's going to produce two products. So this is double replacement reaction. The lead will switch places with the metal, and you're going to get a metal nitrate. So the metal has a +3 charge, nitrate has a -1, so you're going to get MnO3 3. Then you're going to get lead, which has a +2 charge, and that's going to combine with the chlorine. So that's going to be Pb +2 -1 PbCl2. All right, so it's not balanced. I need to do that, so nitrate would be the first thing I would want to balance. We got a 3 and a 2, so let's make it 6. So 2 of these, 3 of these. All right, so I need 3 leads, and that gives me 6 chlorines. So I need 2 of these, and now I am balanced. So now I have a balanced equation, and I have some information. I know that lead chloride is produced and this many grams is made. I also know that I started with 0.944 grams of the substance right here. All right, and we're trying to figure out what the metal is. So in order to do this, it would be good to find the molar mass of this compound right here. So the molar mass is equal to grams divided by moles. So I can figure out the molar mass if I have two things. I do know that I have 0.944 grams. I know that, but I do not know how many moles that is. So if I figure out the number of moles, I can just plug it in, and then I can figure out the molar mass. So let's start with the thing that we know the most about, and that's lead chloride. I don't know the identity with this, so if I start with lead chloride, I can figure out how many moles I have of the lead chloride, or the metal chloride. So I'm going to start with the one I know the most about. I know that I produce 2.23 grams of that, so I can use that information to figure out how many moles of MCl3 it took to make that. So I can go from grams of lead chloride to moles of the unknown metal. Now I want to go to moles because, again, remember, I'm trying to solve for the molar mass here. So I need to get the number of moles. So I'm going to go from grams of the lead chloride to moles of this. Then I can go to moles of the new substance. All right, so I'm going to go to my moles of my metal chloride. All right, so let's go ahead and set that part up. So remember, we're trying to find the moles of the metal chloride because if we know the number of moles, we can just plug it into this and figure out the molar mass. So we're starting with 2.23 grams of lead chloride. So my grams will go on the bottom. Moles will go on the top. 1 mole is equal to a certain number of grams. In this case, it's going to be 278.2. Now we're going to go to moles of the new substance. All right, so moles to moles. We have 2 moles of the unknown metal chloride and 3 moles of lead chloride. All right, so now you're going to do the math. You should plug that in. And you should get 0.00534 moles. All right, so that's how many moles that it took to make this amount of lead chloride. So this is how many moles I had. This is how many grams I had. So now I can solve for the molar mass. Don't know why it's doing that. All right, I'm not sure why it's stretching like that, but I'm going to go ahead and continue so we can just finish this. So remember, I had, trying to figure out the molar mass, I have 0.944 grams of that metal chloride, and I have this many moles, which I use stoichiometry to figure out. So if I divide that, I'm going to figure out that my molar mass is equal to 177 grams per mole. So for every 1 mole of this substance, I should have 177 grams. So, not quite done yet, because I want to know the identity of the metal. So this will help me determine what that is. So I know that my formula should be some metal, Cl3. I know that. And I know the mass of chlorine, and I know there's 3 of them because the metal has a charge of +3 and chlorine has a charge of -1. So I need to know how much the chlorine weighs total. So 35.5 times 3 will give me 106.5. All right? So I know that my total mass is 177. chlorine weighs 106.5 grams. So I can take 177 and subtract 106.5, and that will give me 70.5. All right, so my metal should weigh 70.5 grams. All right, so my metal weighs 70.5. So let's go ahead and look for the metal that weighs 70.5 grams. So let's see, here's 65. Gallium is 69.7. Germanium is 72.63. I do not see something that weighs 70.5 grams, but I know that in labs I have error. So it's not going to weigh exactly 70 when I do the lab, when I take the data from the lab. But I do know something else about this metal. I know that it has a charge of +3. Since I know it has a charge of +3, and everything in group 13 or 3A has a charge of +3, it has to be gallium. So the identity of the metal is going to be gallium. So just really quickly to sum this up, all right, so really quickly to sum this up, here's what we did. We wrote our equation, our balanced equation, and then with our balanced equation, we used stoichiometry to determine the number of moles of the unknown compound. Then we took the number of grams of that compound and divided it by the number of moles that we calculated from our stoichiometry. Then we used that molar mass to determine the mass of the metal. Which helped us to identify what the metal was. That, and we knew the charge of the metal. So that's basically how you would do this. We'll do some more practice in class, and hopefully we'll do the lab that I have planned. But I will see you in class.